Step 17. Let's see what we have to do here. This is a bit more reads in terms of content because there are many things taking place in this step. But let's try to go step by step in this step. First of all, I think it would be better if we just open the script first and then I will start explaining. So I go macros and scripts again and I open the remove rows. All right. To load the start dist kernel, of course, which is loaded automatically. If not, you have to do it. And then I go run Python file. And you will see a bunch of things here that I will start explaining. So in this step, we're filtering our regions of interest, meaning that we can set a specific range, acceptable range, for area, mean gray value, model gray value, and so on. Ignore this part for now because it was experimental and I was just too lazy to take out from the code afterwards. So let's just stay in these parts. This whole step entails that you have done already some qualitative assessment of what is the area that is acceptable for you. So you're having a look at your images, and if you have two large objects that are erroneously predicted as regions of interest, then you can measure this area and you can say, you know what, if it's that big, probably it's not a neuron anymore, so take it out. We will also inspect visually and rectify manually, but we're running this code because we want to have our predictions as optimal, as good as possible anyway. So, and remember, we will be taking the predictions of start-dist, right? And we will just be filtering them more here. So you can set a range for your area, for your mean gray value, and for your model gray value. Now, it is important that for the mean gray value, although it's not written anywhere apart from these instructions, but there's not an information icon here, it is the numbers that you're going to place are not, in fact, the absolute numbers representing the range that is acceptable for your case. It is a bit more dynamic here, and what's actually going on, what is going on is that, remember that we took the mean gray measurements back in step, I don't remember, was it 14 or something? So every time an iteration runs and a specific tissue, in a sense, is studied, right? What it's going to do is that it will look at the mean gray value here. And this is taken for granted as the minimum. So if you want to go lower than that, although I've never tried, but in principle it should work. If you want to go lower and say that I want to be at 200 instead of 225, what you can do here is type -25. Again, I cannot guarantee that the minus will work, but most likely you won't have to do something like that. Most likely you will want to increase it a bit, right? So this gives us the leeway to act a bit more dynamically and say that if I add, for example, here 100, then set as the minimum accepted gray value of an object that has been predicted based on my start-dist network at this value plus this value. And the only stable thing here is that value that you have submitted, right? In every iteration, the program will go through the measurements for each one of these slides, tissue, whatever, and it will find the the respective ROI's mean gray value. So that's the only difference of the mean gray value compared to the rest. I won't put anything at the maximum. For the area, I will put something like 100. And for the model gray value, that should practically be just only one field optimally. There shouldn't be two fields here, but something in the code wasn't running that well, and again, I didn't have the time to fix that, so it is made in the form of a range. So you can leave the minimum blank. If you leave a field blank, what it means that for the minimum it will take a minus infinity practically, and for the maximum a plus infinity. So even if you leave it blank here, it's fine, no worries. And you can go to the maximum. And what your maximum model gray value want to be is 1515, because if I go, and let me actually demonstrate that to you in order to be more clear. All right, I'm opening the white background images, and let's run a measurement. I'm just pressing Control and M now, and I'm running a measurement here. You see that the mode value that I get is 1516 because all the background is like that. So the problem sometimes with predictions is that you have a prediction, erroneous prediction like that, just because the contours make it harder if you haven't robustly trained your network, I guess, very robustly, to make sure that you won't have any of these cases. So if you run again a measurement here, imagine that that was a prediction, right, from Stardist. What's gonna happen is that you will have again a mode of 1516. So that way you can get rid of that. The problem is that with black backgrounds, many times you have something like that, which might give you a mode of 1516, which is the case, but I don't know, maybe not if this whole thing is actually the same pixel. It's not here, you cannot see it, but it's different pixels. And I think sometimes you even have predictions that are completely or almost completely inside, and then you get a different mode and you cannot get rid of it anymore. So that's the idea, and that's the reason we're doing it as we're doing it. All right, so I've set a minimum area of 100. I won't place maximum. I could always do that, but I'm just too lazy right now to search for more information in my data. But you should assess qualitatively a bit of what's going on in your tissue, and you can easily do that, right? Let's say you open an image, and you can just draw a polygon around a neuron of yours. You run measurements, and you can run some of these measurements to know more or less what kind of limits you want to put in the filters. It shouldn't take much of your time, honestly, because you don't have to be super precise here. Okay, so minimum of area 100, uh, an additional of 100 to the mean gray value for its mean gray value of files, and a model gray value that stops to 1515 and excludes anything that's above it. Now it's time to select our folders. So here I am selecting the renamed folders, the renamed predictions, all right? So you really want them renamed, otherwise it won't work. So it's the same predictions, but we renamed them in the previous step. The nuclei measurements, you want to take the nuclei measurements of mean gray and mean gray 1, okay? Well, an issue here, could it be an issue? No, there's no issue with the row size here. So I'm selecting the mean gray for this one. And now we're going to the background measurements, and let's find the background measurements. Oh no, excuse me. Practically the background measurements. That was a mistake. For the nuclei measurements, we use the first measurements. Don't use after manual correction this part. And for the background measurements, we're selecting the mean gray. All right. So again, ROI folder for the renamed predictions, nuclei measurements, and let's just do it again to make sure that I'm doing it right. So name predictions for the ROI folder, nuclei measurements for the first measurements, and background measurements for the mean gray. And as an output folder, I will select this newly created folder, which is called filtered ROIs. And now I just press ready, and let's see what's going on. Well, okay. I'm getting an error that says that a file exists. Okay, I didn't. So I tested it before my tutorial, and I forgot to delete the already generated folders in there, and that was the problem. So now I'm gonna run it again. You might encounter this problem, actually, this error sometimes. So if you encounter it, keep in mind that it could be inside. It could be that something you created is blocking your code from running properly. Okay, I'm running it again then. Okay, sorry about that, but I promise I will be faster this time. 1515, right folder, desktop rename predictions, nuclei measurement first measurements, and background measurements, mean gray 1, and output folder, filtered rows. And now I'm pressing ready. And if everything goes well, you will get this message saying that your analysis is complete and that you can close this window. So what's happened now is that we have newly created and filtered regions of interest, and you will get it in two forms to facilitate for further process. One is in those folders and one is in zip files that you can directly drag to your image state to check what's going on. So in the excluded folder, you will see the regions of interest that have been excluded based on your filtering criteria. Let's test that actually. All right, let's open the first image, and before I put the excluded ones, what I can do, let me actually first make it a bit more visible for you, because I don't know what your screen's brightness is and everything. All right, let's see. Let's say that we have something like that. So what I will do first is that I will find the primary predictions, the unprocessed predictions of Stardust, and these are all okay. So as you can see, we have some predictions in regions that are less bright, let's say. Why? Because if we make this even more bright, then something will start appearing there. But now, if I close this and discard the regions of interest, and if I insert the excluded ones, you will see which ones were not filtered in. And these are the ones that they were not filtered in. So most of them, as you can see, are ones that are either too small, probably, like that one, or not that bright, as in the rest of the cases. This looks more bright. I don't know which one of the cases it might fall under. Let's have a look. But I will do it a bit roughly now, so it might not be that good. But I suspect it's. Let's see. So this is a interesting exception. Okay, it has a mean of 400. So if we see what its mean gray value was, more or less 400, right? Now it should have been accepted. Probably it should be accepted based on the mean gray value. Its size is, its area is small. Okay, is it the case? Let's see. Maybe its area is small, and I should lower a bit my criteria of current measurement. Yeah, my measurement was a bit crude, but I think it's the area that was actually a bit smaller than 100. So I can know for next time that I can maybe change that part a bit. And there are other ones that I'm not exactly sure why they've been excluded, like that. Probably these pixels here create an issue. I'm not sure. But in any case, don't worry about the exclusions, because you will be able to bring the exclusions back. Again, right now I'm doing it quite hastily, so yeah, there is something going on that I have to think of. But no worries, because we can solve it, the ones that are falsely excluded. But overall, you would want your script to exclude uh, more regions uh, than the erroneous predictions. And I think even in this case, this is done. That's actually because now I'm curious. Let's look at one more and see if it worked slightly better at least. We have the zip predictions. Okay, let's open a file. Let's go for file 2 and let's bring that here. So all predictions. So that actually looks better. Huh? I should have used this one, but I'm too honest, so I will not change my video. But yeah, you can see how it works. Okay, this is a bit tricky step, but quite important one. So time for step 18, I guess.